An earthquake is really a rupture or a break of the rocks that happens suddenly. The stress builds up over years, decades, even hundreds of years, but the earthquake happens all of a sudden. Why? Why on that particular day?
Harold Tobin aims to find out as he and his colleagues drill deep into the ocean floor off the southwestern coast of Japan.
The biggest faults in the world are the ones that make the magnitude 9 earthquakes and the tsunamis, and they're all offshore. They're all underneath deep water in the ocean. We'd like to actually get inside the fault zones themselves, deep beneath the surface, in order to learn about the properties of the rocks and what the stresses are and what's building up the strain. So the only way to do that is actually to use a drill, just like sort of the oil drilling field, but using it for science instead of for drilling oil wells, to get down into those faults even kilometers below the surface. We're drilling holes as deep as 4 miles, 7 kilometers below the surface in order to get at those fault zones, because we have to get to where the earthquakes occur, and they occur really deeply. We drill down and we can take core samples, so we can take rock samples, sort of meter by meter as we go along, and look at what that core tells us about the geology. We can also put instruments down in those holes so that we can measure things we'd like to know, very small earthquakes using special seismometers that go in the borehole, or strain of the rock, or maybe the temperature of the rock at those depths, and monitor that over time to look at how it changes in those faults between earthquakes and maybe leading up to the next big earthquake.
In 2006, the team started drilling in the Nankai Trough, a region that has experienced a large earthquake and tsunami about every 100 years. The team has already come up with big surprises.
One big kind of surprise that's revolutionizing the way we're thinking about these faults a little bit is we drilled into the fault actually at a quite shallow position, just sort of a few hundred feet below the surface, and found really good evidence that the earthquake slip had come all the way to near the surface at the seafloor there. That tells us that when one of these deep earthquakes starts, it can rip through the rocks right up to the seabed, and that's really what makes the tsunami potentially so damaging, is when it moves the seabed a lot. So it's really changing the way we look at how these faults go when a big earthquake occurs.
Tobin also runs a geoscience visualization lab at the University of Wisconsin-Madison that creates 3D models of the drilling locations.
There's also a very practical goal, is once the beginnings of an earthquake rupture start to happen, how quickly can an early warning be formulated? And how quickly can we estimate that it's not a little earthquake, it's really a big one that's starting, and over just seconds determine that a warning needs to go out to, say, nearby populations? And so wiring up this fault zone off the coast of Japan is one way of getting at that problem, and then getting the data back real time, onto the internet through these seafloor observatories, so that those kind of warnings can go out.
Warnings that might save lives on the particular day when an earthquake strikes. We can never know exactly when the next big one will occur, but the work of Tobin's team can help us determine the likelihood and timing of these events.
About a year ago, the Deepwater Horizon drilling rig exploded and sent oil gushing into the Gulf of Mexico. Over the course of the next 3 months, almost 206 million gallons of crude oil spilled into the Gulf until the well was finally capped. At the time of the leak, 3 local scientists did what they could to get involved in the disaster.
I just decided to really just jump in and go and see how I could help, in any way.
The sea turtles that Jay studies were heavily impacted by the oil in the Gulf.
I originally thought that I was going to be on boats, reaching into the water and plucking turtles out of oil. And what I ended up doing was something kind of different. I got on an airplane and we flew aerial surveys, and I got to survey the whole spill area to look for wildlife, to look for sea turtles and other animals, and to report that back. I immediately got really a bird's eye view of what was going on, and access in a way that I really hadn't expected. And so I of course had my video camera along, and I collected a lot of footage that I shared. Lots of people at CNN gobbled it up because they didn't have access.
Thomas Aswell found himself at the Gulf without a plan as well.
When I heard that there was a spill there, and it was a spill that was significant, I felt obligation to try to do something. And so I got involved with a group that is based out of UC Berkeley. It was a study group called the Deepwater Horizon Study Group that was advising the National Commission on their investigation of the spill.
Thomas and Jay took a big picture approach to inform decision makers, while Peter Rupnarayan and his colleagues took a decidedly more narrow view.
We started working on the oil spill within 2 weeks of its occurrence last year. We were interested to know if we could detect elements from crude oil in the shells of molluscan animals, so clams, snails, and so on.
It turns out you can read these animals' shells like tree rings. And Peter knew from previous work that crude oil can leave its marks in the shell in the form of hydrocarbons.
So what we need to do is to ensure that any signal we detect in the shells that we've been collecting since May last year can actually be attributed to Deepwater Horizon, and it's not sort of natural levels of contamination that are in the bay.
A year later, the work continues for all three researchers.
We detected the presence of vanadium and lead in shells collected in August. We're fairly certain that the vanadium is a Deepwater Horizon signal.
While Peter and his colleagues continue to test the shells, Thomas returns often to the Gulf.
There's still oil sitting at the bottom of the Gulf. There's research at the University of Georgia that's finding this in very deep water, and I see this in very shallow water.
Thomas is currently working with agencies to hopefully remove remaining oil, and he's also looking toward potential future spills, learning from mistakes made here.
And now that I've finished my report to the Obama administration, really looking at what's going to happen going forward, the information that I gathered from the cleanup effort and the response, and putting together some new regulation so that we incorporate better technologies and a better response so that it's more focused on containing and recovering the oil from the environment and minimizing that impact.
The future of the world's oceans, boy, if you had asked me when I first started studying them, I would have thought limitless. It can only get better. New technologies were being developed. Scuba diving was in its infancy. It was such an exciting time. Now that we've developed all these technologies, now that we have plundered the oceans so exhaustively, I can't predict what will be left for the next generation.
I'm fearful for the future of the oceans.
It's a time for great concern.
I think the future for the oceans overall is a fairly grim one because we're not taking care of the oceans.
We don't know what the future of the ocean is, but it's pretty scary and pretty ominous.
There are so many different assaults that humans cause in the oceans.
With overfishing,
pollution,
runoff from the land,
movement of exotic species,
oil spills, dredging,
ocean circulation disruption,
overexploitation of species,
habitat destruction,
coral bleaching.
Climate change is going to have profound impacts on the ocean marine life, and we just don't know how bad it's going to be, but it's probably the most serious issue that we face.
I'm not hopeful about the future of the oceans, but I'm optimistic that with the next generation of children that visit this museum, children that visit the ocean, children that read, children that care, they won't let us get away with what we've been doing for the last 2 generations.
I'm choosing to believe the future of the oceans is all good. I want to believe that the problems are not insurmountable, that we can come together and figure out a way to deal with them and stick to it. And in a large extent, I have to think that way because I have a 7-year-old daughter and I want her to have the oceans.
The future of our oceans is certainly in our hands, and really now is the time to decide what we want the future of the oceans to be.
It's not too late. No matter who you are or where you're living, you have the ability to make that change.
We've never had more information about how to improve the oceans, about how to solve some of these problems. It's a challenging time, but it's an exciting time.
We can all help if we do just a little bit, and altogether they'll add up and make a big impact.
I have to trust that there are people around the world just like me doing the best that they can to engage and educate people in their communities about the ocean's health.
And I can grab and shake people and say, look, pay attention. It doesn't have to be this way.
So there is that hopefulness that I try to carry and keep in my heart.
It's worth saving.